How would you solve a system with 3 equations and 3 unknowns? Now this is the same type of problems that we were dealing with yesterday, except yesterday we did mainly elimination. Today I'm going to show you how you would use substitution. You do not have to use substitution. You can do elimination if it works better for you. So if I wanted to be able to do substitution, I need to have a variable that's easy for me to get by itself. So for example, if you'll look at that first equation, notice that I have an x with a coefficient of 1, a z with a coefficient of 1. Either one of those would be easy to solve for, just to get by itself. And in that bottom equation, I have a z that has a coefficient of 1, so that one would be easy to get by itself. So what I'm actually going to do is I'm going to take that top equation and I'm going to get x by itself. So if I had x minus 2y plus z equals -4, so just to get x by itself, I would need to add 2y to both sides, and that would leave me with x plus z equals -4 plus 2y. Then I would need to subtract z from both sides, and that would leave me with x equals -4 plus 2y minus z. So now basically what I could do is I could plug -4 plus 2y minus z into these other equations for the letter x. So where the x is in this equation, I'll actually replace that with -4 plus 2y minus z. And then the last equation, you would plug it in right there. So for that second equation, that would be -4 times -4 plus 2y minus z, and then plus y minus 2z equals 1. And then you would need to simplify that. So that would be distributive property. So 16 minus 8y plus 4z plus y minus 2z equals 1. Combine your like terms. So if I have -8y and a positive y, those are both on the same side, so we just combine them. That would be -7y. And then there's a 4z here and a -2z here. So if I combine those two terms, that would leave me with 2z. Then you're left with this 16. Well, so I actually want to move the 16 to the other side of the equal sign. And the only way to do that would be to subtract. So if I subtracted 16 from 1, that leaves me with -15. Now I've got to repeat this whole process with that third equation. So I would take the bottom equation and I would write 2 times -4 plus 2y minus z plus 2y minus z equals 10. Then I do distributive property. So that would be -8 plus 4y minus 2z plus 2y minus z equals 10. Simplify that by basically combining your like terms. So I've got a positive 4y, positive 2y, that would be 6y, -2z minus z, -3z. And then this -8 right here, I actually want to move it to the other side. So I would have to add 8 to 10, which would give me 18. So now I have two equations where both of those equations only have a y and a z. So now I have to take those two equations and either do substitution or elimination with those two equations. So if I started with -7y plus 2z equals negative 15, and 6y minus 3z equals 18. Well, in order to be able to do elimination, I'm going to have to get the same coefficients in front of the y's or in front of the x's. And I'm going to have to multiply both equations by something. So if I multiply this bottom equation, let's just say by 2, and I multiply the top equation by 3, now the z's would have the same coefficient. So slide that over. So that would leave me, this new equation then would be negative 21y plus 6z equals negative 45. So I multiplied everything by 3. The bottom equation would be 12y minus 6z equals 36. Then from here, because the z's have opposite coefficients, we could add everything. Be careful, this is where a lot of you were making mistakes yesterday. Negative 21 plus 12 would be 9y, or negative 9y. 6 plus negative 6, well that's 0, that cancels out. Negative 45 plus 36 would be 9. And then I would just divide both sides. I'm sorry, that would be negative 9. So now I would divide both sides by negative 9. And that leaves me with y equals 1. So that's just one answer. I had to do all that work just to get to one answer. So now that I know what y equals, I can go back to one of the two equations that I was just working with. So I could go back to this one or this one. It really didn't matter. You could also go back to this equation or this equation. It doesn't make any difference. Just pick one of them and go with it. Because now that we know that y equals 1, if we go back to that equation that I originally wrote in blue, so that would be 6 times 1 minus 3z equals 18. Simplify. 6 minus 3z equals 18. Subtract 6. We're left with negative 3z equals 12. And then if we divide by negative 3, we get z equals negative 4. So now that we have y and we have z, we can find x by looking back at that negative 4 plus 2y minus z. So if x equals negative 4 plus 2y, well now that's going to be 2 times 1 minus z. Well, z is negative 4, so that would be minus negative 4. And then I just simplify. So that would be negative 4 plus 2 plus 4. Well, negative 4 plus 2 plus 4 would just be 2. So my solution here should be 2, comma, 1, comma, negative 4. So that would be my solution for that system of 3 equations. Substitution can be a lot lengthier than elimination. So if you like elimination, stick with it. If you like substitution, stick with it.